So here is some class data for that measures work satisfaction, or the quality of one's relationship with one's boss. And it collected like the survey that we had in our class. And we've got data for a bunch of students here, and they're all APU students who participated in this. And suppose that the population mean, the national average for this measure of quality of relationship is 3.5 with a standard deviation 0.7. We want to test the hypothesis that organizational psychology students at APU are more satisfied with their boss, or than more satisfied with their boss than the typical person is. So we can clarify here what our hypothesis is. Hypothesis: APU org psych students have better relationships, because this is kind of a measure of relationship quality, with their bosses than do the average person. So we're predicting average rather than difference. So this is a one-tailed test. One-tailed, this is a one-tail hypothesis. If we hypothesize that they had worse relationships, that would be a one-tailed. But if we simply predicted that they had a different average, that would be two tails, because it could go off in any direction. All right, so that's our one-tailed hypothesis. Now let's go copy our z-test calculator. Still highlighted from the last problem, so I'll do control copy, go back to this equation, and I'll put this over here, control V. And now we need to copy the data into the calculator. So it can highlight it all, the downshift arrow, control copy, and paste with control V. And let's change the name of the variable to, let's call it relationship quality. And we can make it a little wider so we can see that. And we need to put in the population and the population standard deviation, because this is just random numbers that were in there. So the population average should be 3.5, and the standard deviation is 0.7. All right, now n equals 25, that's the number of our sample size. So the x bar, the sample obtained, was 3.92. Now we look at that and we say, oh, that doesn't seem much higher than 3.5. Maybe there isn't really a difference. We could expect that much by change. But actually, this is a pretty good size sample, 25, and our z obtained is actually 3. So the probability for a one-tailed test of getting a z-score that high is pretty low, 1 in 1,000. So we can conclude, so our conclusion here, let's move things over, gain more space here. Our conclusion is that we can say our one-tailed hypothesis that APU org psych students are more satisfied with their boss than is typical is confirmed. One-tailed z-test indicates that the average level of relationship satisfaction of org of APU, we don't want to make it ambiguous, APU org psych students And so that's, what do we have? We have mean, that's the APA form abbreviation for abbreviation, equals 3.92, and the mean 3.92, n equals 25. The sample size is 25. Be sure to put spaces before and after the equal sign. The average level of relationship satisfaction of APU psych students is greater than the national average, and that was mean equals 3.5, standard deviation equals 0.7, close parentheses, and then we can put a comma. We could have put this in the parentheses also, but I'm going to put it outside of there. We have to decide what the statistic is. So Control I is for italics, Z, turn off the italics, space, equals. The Z is 3.00, and the Control I, P, Control I off, P equals 0.001. And so everyone knows that since P is less than 5, this is significant. So that's how we can write up our conclusion. Our one-tailed hypothesis that APU org psych students are more satisfied with their boss than typical is confirmed. A one-tailed z-test indicates that the average level of relationship satisfaction of APU org psych students, mean equals 3.92 and equals 25, is greater than the national average, where the mean was 3.5 and the standard deviation 0.7, with a z of 3.00 and a p of 0.001.